So our goal is to start with linear regression, simple linear regression. Later on in chapter 13, we will get into multiple linear regression. When we do multiple linear regression, we're going to primarily stick to software because it's difficult to do it manually. You need upper-level math. So, what is simple linear regression? You should know this. What does linear mean? Straight. Then, what is the root word in linear? Line. So the underlying pattern is a line. Chapter 11, we wanted to determine the association between two variables. Those two variables were qualitative. Agreed? Categorical or qualitative, in the sense, good example, marital happiness. We measured it as happy, not happy, very happy. General happiness, not happy, very happy, happy. So those are all qualities or attributes. So those are categorical data variables. When it comes to regression, the data variables are quantitative. What is the key word there? What? Quantity. So in other words, we can measure them as a number. So data are measurements, measurable. Height, weight, blood pressure, heart rate, all of these can be measured. So if the data variables are quantitative, then we have to use linear regression to determine the connection between two variables. So what are the two variables? We already saw that. It's y and x. So y equals f of x. Might be wondering, man, this again was hard to get through college algebra. Now it's back. What does y equals f of x mean? Things that you have nightmares about. Frequency.
Function.
Huh? What?
Function.
F stands for function. So y is a function of x, right? So y in statistics is what we call the response variable or the dependence variable. We already went over this in chapter 11, response dependent. What did we call x in chapter 11? Explore.
Explanatory.
Explanatory variable. But we've got other words too, or independent variable. And very unique to regression, we also call it as the predictor, because the value of x will be used to predict the value of y if you have a good model. All of algebra, college algebra, when you guys took those courses, you might have seen y equals, for instance, 3x minus 2. Yes? And your professor then would have simply asked, well, plug in x is equal to 1, find y. How do you interpret this line? Do this, do that. And then would have explained what 3 is and what 2 is, hopefully. What is 3? Good. What is 2 or negative 2?
Y-intercept.
Y-intercept. Okay. Slope. Y-intercept. So if you want to define a line, you need two things: slope, y-intercept, or 2 points. Because if you have 2 points, you can come up with slope and y-intercept. Does that make sense? So if this is the equation, I can plug this equation in the calculator, come up with a nice little line. Do you agree? Okay. Now statistics doesn't deal with that. It sort of uses that. So the goal of statistics is to find that function. What is that function? How do we find that function? First, we obtain something called a scatterplot. Each of these dots represents a data observation. Good. How many do we have? 11. Now, by the looks of it, do you believe that there is some sort of an association between X and Y?
Yes.
Yes. And if that is the case, what type of function could possibly explain that relationship? Don't answer yet. Could it be a line? Could it be a parabola of that sort? Could it be a sine curve? Or could it be an exponential? You've got these 4 options, and I ask you, which one of those 4 would be a good candidate to explain this data? Which one would you pick?
The line.
The line, right? That looks like a line. So it's only smart to use a line. Now, here comes another issue. Well, if it is a line, only 2 comments. Is it that line? Or is it that line? Or is it that line? Of the 3, which one would you pick? What? The red. Why? Go ahead.
It has the most points on the line.
It has the most points on the line. Sort of is true. Also, what else comes to your mind? It's the line of best fit. Okay. You just jumped 2 steps and went forward. But it's a good answer. Do you have an answer?
There's like an equal number of dots above and below.
Equal number of dots above and below. So what Josie is trying to say is this line is finding a way to sort of divide the observations, relatively equally. In other words, it is trying to pass through the middle as much as possible. Yes? What's your name? I forget. Hector. Hector said the line of best fit because you can draw infinitely many lines through that data. But out of all those infinitely many lines, only one will represent the data the best way possible, which is why we call it the line of best fit. So in algebra, the slope was given to you, the intercept was given to you, or 2 points were given to you, and you found the line. in statistics, the goal is to make use of paired data. In this case, how many paths do we have? How many?
11.
11 paths. To estimate the value of the slope and intercept. The goal here is to come up with the slope and intercept, not just using 2 points. If it's 2 points, I'll get a perfect line. I'm not looking for a perfect line. I have a whole bunch of variability here. I'm trying to come up with a line that will best represent all of these points in a proper way. Does that make sense? So is line the only function that you can use? No. Line is the simplest case. Of course, you could use those. Nonlinear regression. There is logistic regression. We will cover that too, which is interesting and quite often used in social sciences. Sometimes, let's say y is the height of, people. X is the weight of people. Right? Height and weight are connected. Yes. And if I collect the height from Hector, I've got to measure Hector's weight. Yes. I can't get it from Hector and go over to Thomas and record his weight. Right? Doesn't make any sense. Which is why we call it fact. The observations must go together. But would there be always only a single variable that would explain height? In other words, is weight the only thing that would explain a person's height? No. Many of you say no. What else could explain height?
Genetics.
Huh?
Genetics.
Genetics. Okay, what in genetics? That's a broad thing. I mean, by genetics, do you believe in genetics or do you not believe in genetics? Specifically, what are we talking about, Hector?
It's you inherited from your parents.
Traits that come from your parents. Okay, give me one.
Their height. Like
Their height. Okay, good. Fine. Parents' height. How about that? Your height might be actually related to your parents' height. What else? What?
Like the environment.
How about
Environment, don't worry.
gender? How about ethnicity? How about the place where you were born, right? The continent you were born. All of these could have an association, in which case I no longer have one X. I have weight, which is X1, genetic traits such as parents' height, X2, continent you were born, X3, gender, X4, I should call it sex, X4, ethnicity, X5, whole bunch of variables. That is what we call multiple linear regression. So for us to understand multiple linear regression, we've got to understand this first. Good place to stop. I'll see you on Thursday.